My name is Peter Pigatti, and this is my MEMS 5001 Final Project Progress Report. So the concept that I've been working on is optimizing a muzzle brake for a 5.56 rifle, and I'm be doing that by writing a genetic algorithm in MATLAB and testing my solutions in a SolidWorks simulation. The optimization goals so far have been to maximize the forward thrust force to counter recoil while minimizing the overall length and size of the device. So progress so far, my optimization parameters have been the number of baffles on the device, the size of the baffle ports, the distance between the baffles, and the angle of deflection. The calculations have been based on a basic thrust equation, which is just a change of momentum, so that force equals velocity times the mass flow rate in the baffles minus the mass flow rate coming out of the barrel. Mass flow rate is calculated by the density of the gas times the velocity of the gas times the area of the port. And you can see that by the fitness function down below. That is what I've written in MATLAB code so far, and I'll continue going on to show how MATLAB is working. So the constraints are that the device is less than or equal to 3 inches long. It's also constrained to be 0.65 inches tall and 0.75 inches wide. This is to accommodate a standard government style barrel. The distance between the baffles has to be greater than the size of the baffles. This is just to constrain the actual variables themselves to give them something to shoot for. The gas being used is considered to all be CO2, as the burnt powder in the barrel is converted to CO2. The minimal amounts of other gases don't really matter in this optimization. And with a 16-inch barrel, it gives a muzzle velocity of 2,800 feet per second for this kind of ammunition. And you can see below the constraints being put in, both in the linear and nonlinear constraints, with the big box and the small banner on this slide. This is an example of my SolidWorks simulation. This simulation was done with a brake of just arbitrary measurements. It was just created to test in the first place and see if I could get the simulation to do what I wanted it to. Obviously, you can see the flow lines in the actual part there with pressure values, and a force reading measuring the forward force from just 1/2 of the muzzle brake. So that value would be multiplied by 2 to get the total force. And that is in pounds force, not newtons. So issues that I've had so far is the MATLAB code is seemingly ignoring the constraints. You can see that this thrust value is ridiculously high, and so are all of the variables, the number of baffles, the width of the baffles, and the distance between them. These are all ridiculous values in the millions and the billions. The width of the baffles there is in the tens of thousands, which being in inches, that's just ridiculous. Obviously, clearly higher than the 3-inch limit that we have on the total device. So these kinds of issues are being worked through with Professor Tequila and with the TA, and we will hope to resolve these so that they can get the code working properly, so they can start testing some of the generations in SolidWorks simulations with a proper set of variables.